morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. How's everybody doing? Good? All right, so warm-up 119 should come up on your screen. Focus, please. And today we're moving on. We're going to start in closing this school year with this last module. That's why I'm locked in. We're about to embark in our last mathematical journey for your Imperial High School career. What? That's crazy. Also, thanks some of you that went on Friday to enjoy a good afternoon with the teachers versus students basketball game. It went pretty well. I was rocking the mic. Let's go. All right, and once again, reminder, mobile devices, put them away. If you notice, they're already starting to come into the classrooms. They were across the way not too long ago, and we're going to have folks walking in, so stay focused. Once you're done with your warm-up, come get a handout from over here. We're moving on. Let's go. Mu, let's see. Who? Lisa? She's not, so my third period. All right, thank you. We'll probably come back. Where was I? Mu. Letter M for Mario. Mu, what'd you get? 20.8. Looks about right. Hands, have you got that? All right, let's go to standard variance. Got someone, Mario? Max, variance. Santi, help him out. What'd you get? 174.2. Pretty close. Need a standard deviation, pass someone. Aaron? 13.2. All right, so that takes us to 34 on the up end. And on the other, we have 7.6. So that means our norm is from 7.6 to 34. We good? All right. Z-score. I wonder if I should go back to where we started over here. Z-score. Tell me there what you got for the Z-score before Max enlightens us with a Z-score for 25. I already did it in my head, and it should be done by now. See, 4.2 divided by 13.2, that's 0.3. Maximus, what'd you get? 0.35, close enough, 0.35. So 0 is here, 3.5 is about 1/3 up, right here. And that is our Z, and what do we know about that number 25? According to the Z, that's in the what? In the norm. Okay. And the range being 40 minus 5, that's 35. All right, send that in, please. Did I send you the screen already? Yep. All right. And copy the agenda right after, and make sure you make your way over here and grab one of these handouts, please. All right, so agenda, be nice. Agenda. Warm-up 119 done. Normal distribution. We're moving on. Tonight's home plate, 10 problems only. Only. So, before I forget though, do me a favor, go to Canvas. Is it being recorded? Yes, it's being recorded. Go to Canvas really quick. Go to my class. Go to grades. Take a screenshot. That's due tomorrow as you walk in. I did a quick update on grades. Some of y'all are playing too much. Some of you are behind. I don't know why. This is probably the easiest class that you have all day. I mean, being that it's a rigorous course, but it's the easiest one, I think. So, make sure you get that signed. Have your parents take you to McDonald's, get a Happy Meal or something. All right, we good? All right, so 10 problems done. Here's the code to access the home plate. S7WFN. Write that down, please. S7WFN. And as I mentioned today, we're starting the last module of the school year today. We're getting really close to our having you guys bring your books back already. What? Ooh. It's only $185. Let's go. Only. All right. Thank you. All right, we good? All right, get a Cornell note ready, please. Oh, there's your home plate for tonight. Let's go. All right, get a Cornell note ready, please. I can define and compute normal distribution. I can define and compute normal distribution. Set that up, please. Okay, we good? All right, here we go. So, normal distribution. As I've been getting you guys ready for this last push of the course at the end of the school year, I'll tell you this. This is the section that gets most college students to drop their statistics course. However, you guys do most of the stuff in 5 minutes, which is the warm-up. Why? Because I've been getting you guys ready for today. Today, we're just going to add a couple more pieces to the normal distribution, but other than that, you should know how to do everything that this unit has. Does that make sense? So pretty much I have you guys lifting weights all year on that warm-up every day. Thank you very much for putting in that effort. Normal distribution. Before we get there, we already talked about classic, empirical, and subjective probability. We talked about variables, is that correct? And we talked about discrete versus continuous, is that correct? We know the difference from one to the other. But now we're going to focus from this point forward on continuous variables. We finished with discrete. We already have all those formulas down, and I can give you a pop party today just to yourself, and you know all the formulas. All right? So, where are we going? So here's the normal distribution, also known as what, everyone? What do we call this? Bell curve. That is correct. That's known as the normal distribution. But there's others. There's this one called skewed left, and this one called skewed right. And if you notice, what's the difference from one to the other? Well, this one has a big gap over here on the left side. This one has it on the right side. However, look at the mean, median, and mode for the left. We have the mean on the far left, and we got median and mode. Look at the one on the right. We got the mode, median, and we got the mean all the way to the right side. However, look at the normal distribution. Where do you see the mean, median, and mode? Right at where? At the center. Now, let me trigger your noodle. What do we call mean, median, and mode? Remind your neighbor. What do we call mean, median, and mode? Looks like Lulu's got it. Very good, Lulu. What do we call mean, median, and mode? Let's go with someone with the letter M. Mean, median, and mode. Let's go with Mario. What do we call mean, median, and mode? Measures of central tendency, hence the word what? Central or center. And what do you guys notice where all of them are in regards to the normal curve? They're in the center. Does that make sense? All right, copy these three, please, on your notes, please, and I'll send you a screen so you can show me what you did. Copy those three, please. Then you send those to your screen. All right, so we have symmetrical, skewed left, and skewed right. Right now I'm going to focus on the normal curve. Y'all ready? All right, so the normal curve, add this to it. Add some percentages between -1 standard deviation to +1 standard deviation. That percent is 68.26. Between -2 standard deviation and +2 standard deviation, that is 95.44. And between -3rd standard deviation and +3rd standard deviation, that's 99.72. Add that to your curve, please. And then to break down, those percentages are pertaining to underneath the curve. So here's the breakdown on the percentages. Write those down, please. So, once again, these percentages are for the area under the curve. Tell your neighbor what I just said, please. So what does that mean, Mr. Q? That means that all those percentages that you see, all of them, all these, are for under the curve. The only thing that we're missing is these at the end. These right here. This little piece right here and this little piece right here. All right. So question. You have your calculators. I want you to add all these percentages. What does that give you? What do those percentages give you? Then Maximus is going to enlighten us. What are those percentages? There are calculators back there. Bless you. All right, what'd you get, Maximus? 99.72, that is correct, because that's the number I gave you over here on top. That is correct. All these percentages should add up to that. However, we're missing two percentages. What do we need to do with this number to find the two percentages that we're missing? Talk it over to your neighbor. What do we need to do? What do we need to do? Let's go with D. David. What do we need to do, David? Help him out, Aaron. He said take 100% because that's the entire area under the curve. Subtract the 99.72, and that gives us 0.28. Is that correct? But we need to split it into two. Is that correct? So at the end we divide by 2. So these are 0.14, 0.14. That is correct. So how much is the percent under the curve, everyone? The entire percentage is 100. Okay. So, with that said, writing utensils down, look up. What if I did this? Here's mu. Without using calculators, Tell your neighbor the area in percent to the left of mu. Area in percent to the left of mu. Mu, mu. Percent to the left of mu. Let's go with Mel. Mel, what is the percent to the left of mu? 50%. That is correct. Why, Mr. Q? Because mu is right in the middle. That means to the left is 50, to the right is 50. Does that make sense? Yes? All right. Well, today, we're going to be converting z-scores into percentage under the curve. Now, by now, I assume, since you guys have been doing your warm-ups every day, that you know the formulas to the z-scores. Tell your neighbor the formulas to the z-score. What is the formula to the z-score? Formula to the z-score. Let's see. Whose name has Z? Z. Let's go with Z. What is the formula? That is correct. X minus X bar over standard deviation. There it is. This is for the sample, and this is for the population. We know those, right? All right. Get this in front of you really quick. So I just gave you guys a chart with decimal form of percentages for the bell curve. Now, if I was to draw a picture of this, look up. What I'm going to show you is this. I'm going to draw a line straight down the middle. Look up, or you're going to miss it. And that line straight down the middle is like if I'm drawing a line straight down the bell curve. Tell your neighbor what this is. What is that line? That is correct. That is mu. That means all of these to the left are my percentages to the left of the bell curve. Is that correct? All of these on the right are percentages on the right of the bell curve. Are we there? So watch. Let's go back to the warm-up. There's a warm-up. Go to your warm-up, please, really quick. And this is 0.35 that Maximus gave us for the z-score. Okay? So, what that chart gives us, look up or you're going to miss it, is the percentage to the left of the z-score under the curve. The percentage to the left of the z-score under the curve. So what was that z-score? 0.35. Since it's a positive, it's on what side of mu? On the right side. That means, look up, if I go to my chart, I'm not going to look at the ones on the left. I'm going to look at the ones on the right. Is that correct? So what was that number? 0.32, was it? 0.35? All right. So we're going to find z 0.35. Ready? I'm going to show you how to read this. So here's mu, and I need to find 0.35. First things first, go here where it says z and find 0.3. 0.3. Do you guys see it? All right, with your pencil, underline that, 0.3. Next, but that's only, look up, that's only that one. What am I missing? 0.5, is that correct? So I go to the top, and I want you to start at 0.0, go all the way to the right till you get to 0.05. Underline that one. Once you find the two numbers, go one from the side, one straight down until you intersect them and find that decimal form. What is that decimal form? 0.6368. Is that correct? All right, so let's go back to our warm-up. 0.6368. 0.6368. So, all this area is 0.6368 in decimal form, but I want it in percentage. Tell your neighbor what to do with that to make it into a percentage. Yeah, you move the decimal twice, so that means this is 63.68%. That means the area to the left of that Z-score is 63.68%. That make sense? From 1 to 5, how comfortable are you with that? 4, 5, 4, 5. Okay, let's do one together. Here we go. Copy this one to your paper. Find the area to the left of the Z-score of 2.06. Area to the left of the Z-score of 2.06. Write that down, please, so we can have at least one example complete. Example 1. I sent it to your screen. Once again, it reads, find the area to the left of the Z-score, 2.06. So first things first, let's sketch our bell curve so that we can picture it where it's at. So draw a bell curve. This is exactly how the home plate is going to go. One standard deviation to the positive, 2 standard deviations to the positive, 3 standard deviations to the positive. I'll just do 1 to the left for the negative. All right, where's 2.06? Show your neighbor where 2.06 would be at, our Z-score. Where's that at? Show your neighbor, please. Where's 2.06? First, let's just sketch it first to see where it's at. All right, help me out. Let's go with, well, we called on in a while. Let's go with Cole. Cole, 2.06, where do I place that at? No. Where do I place it on my bell curve first? On the right? Tell me where to stop. All right, pretty close. All right, so that Z-score is 2.06. But now we need the area. What is the percentage of the area to the left of that Z-score? All right, so 2.06. What do I do from there? Pass someone, Cole? Brandon Doherty. You go to our chart, and what do? Okay, on the left chart or on the right chart? On the right, so we look for the 2. So let me zoom in. Hold on. The 2, okay, I found it, which is down here. Here's the Z. 2 is right here. And then 0.06 on the top. And then where they intersect, that number is 0.9803. Hands if you got something like that. So this is 2.0, and over here 0.06. So 2.06 is 0.9803. Yes? All right, so let's write that down. Let me zoom out. This part is 0.9803, but in percentage, what is that, everyone? 98.03%. All right, some of your notes, please. From 1 to 5, how comfortable are you with that? 1 to 5, 5, 5, 5, 4. Okay, go ahead, Brandon. All right. So, let's do another one. Copy this one, example number 2. Find the area to the left of Z equals negative 1.67. Find the area to the left of z equals negative 1.67. Find the area to the left of z equals negative 1.67. Once again, start with your bell curve, sketch your z, shade the area, and then go and find the decimal equivalent. I'll give you some time. Go. All right, Mario, where do I place that z? To the left. Tell me where to stop. Right here? All right. So, yeah, that is our z, negative 1.67, but we need the area to the left. All right. Mario, what was that decimal? Zero 475. Hands, we got 0.0475? That is correct. And in percentage, we move the decimal twice, so it's 4.75%. Hands, have you got that by yourself? Okay. All right, so from 1 to 5, I'll compare you with that so far. Yeah, 5, 5, 5. Send me your notes, please. Let's do another one. Let's go. You're like, Mr. Q, just give us a pop part two already. Let's go. Number 3. Find the area to the right of Z128. You're like, what? Yeah. So, copy that one, please. This is a little bit different, but you should be able to use some rationale to get that number. Find the area to the right of z equals 1.28. Write that down, please. All right, first things first, we need our bell curve. All right. Let's go with Carter. All right, Carter, tell me where to place my Z1.28. Starting at mu, where do I go? To the right? Right there. Pretty close. Hands if you got something like that. All right, so that is Z128. Okay? So the number that you get from your chart is going to give us the area to the left of that Z. Is that correct? Yes, Mr. Q. What is that decimal number? Pass them on, Carter. Cole. Right now we want the one on the left. 0.8997. Hands if you got that initial number. Okay. But that's for the left. We want, and this is what? 89.97%. But what does this one say? To the what? We want the number to the right. Tell your neighbor what to do to find that area on the right. All right. Cole, pass someone. Carter, what do I do? That is correct. Subtract that percentage from 100, and that should give us the area to the right, which is 10.03. Hands, if you got that? That is correct. Ooh. We're in fuego. Send me your notes, please. Before I move on, explain to your neighbor what we just did so that they can do the next one by themselves completely. What did we just do? Talk to your neighbor. All right? Explain it to us, David. What do we do? Yeah. Yeah, so we got the first decimal, turned it into percent. That gives us to the left of Z and subtract from 100 to get the one on the right. Okay. All right, let's do another one. Example number 4. You should be able to do this one by yourself. Find the area to the right of Z equals negative 2.23, Michael Jordan. Z equals negative 2.23. I'll give you guys some time. Copy and go. All right, let's see. Walk us through this one. David, pass them one. Santi, what do I do first? Here's my bell curve. So starting at mu, where do I go? Okay, tell me where to stop. Okay, right here. A little bit further away from the second on the negative standard deviation. That's our z-score. We're going to find first the area to the left of that. And then we go to our chart. Here is our chart. To the left, it was 2 point what? 2.23. So if I zoom in, hold on. Let me zoom in. 2.2, yes. And then 3. 3 is right here. So that gives us 0.0129, is that correct? 0.0129. Now, 0.0129, which is 1.29%. But we want the area to the right of that. What do I do with that, Maximus, to find the area of the right? Because this is the area to the left. Subtract from 100, and that gives us 98.71. Hands, if you got that, percent. From 1 to 5, how comfortable are you with this? 5, 5, 5, 5. Okay. You guys sent that in already? But what if I gave you something like this? Find the area between two z's. Copy that one, please. This will be our last one. Hurry up, hurry up, hurry up. Find the area between z 1.68 and z negative 137. All right, so I'm going to do the first z, 1.68. It's about right here. I need a decimal for that. All right, Alessandro, what decimal did you find for 1.68 on the right side? And what? 9535. Okay, so that's 95.35%. All right, let's look to the other z. The other z I'm going to do in green is negative 1.37, negative 1.37, which is here. And I need the area to the left of that one. What number do we get for that one? Vanya. 0.853. So that is 8.53%. Okay. However, I just want this area. Tell your neighbor what to do at the end, just to find that area. What do I do? Brandon Darty, what do I do? Yeah, subtract the 2%. 95.35, subtract 8.53. Calculators calculate. What is 95 minus 95.35 minus 8.53? What is that number? What is it? 86.32? 82. And that is the percent between the two z-scores. From 1 to 5, I'll come through you with this. We got it, right? 5, 5, 5. 283, yeah. All right, we'll stop right there. Make sure you put in some work on your home play. Please, pretty please. It's those 10. Those of you following on YouTube, put in some practice. See you guys next time. Peace.